Day 5. What have we got? Hi and welcome to another episode, and what we've got here is the PiHut Advent Calendar Let It Glow, and we're on to day 5, so let's open it up and find out what we've got. We have some more wires by the looks of it. Oh, a little red thing as well. Let's pull the wires out. Jumper wires. And little red thing. Oh, dip switches. There we go. Dip switches is basically just a little row of tiny little switches that are on and off, and they're numbered 1, 2, 3, 4, 5. So I bet we're going to do something with the 1, 2, 3, 4, 5 or the 0, 1, 2, 3, 4 LEDs. So let's jump across to the website and find out what we've got to do. There we go. As always, make sure that your Pico is unplugged before you start messing around with anything. So let's just push these out of the way for the moment. Come down on the website, chase the mouse around. There we go. Right, it's day 5 of Let It Go Maker Advent Calendar. Yeah, sure is. Today we're using a new control component, things that our environment can interact with to trigger our code, which can then make our LEDs and other blinky bits light up. Fair enough, that's what we guessed. So the funny looking little red block on the box today is a 5-way dip, or a dual inline package switch. So that's what the dip stands for, dual line package. Similar to the bar graph display in yesterday's box, this compact component is like having 5 on-off switches in a teeny tiny package. We can use them with our GPIO pins to select which parts of the programs to run, including color, speed and other things, or we can use them in their most basic form as a simple break in a circuit, so basically an on-off switch. Let's get to it! Right, box number 5 contents is the dip switch and the male-to-male jumper wires. We know that, okay. Today's activities. Today we're going to learn how to use a dip switch, including writing it up in the GPIO pins. We'll use 5 tiny switches to trigger different GPIO pins, high and low, and show you how to trigger your code using multiple switch positions. First, let's tell you a little more about today's component. So blah 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 about the dip switch. So it's not a Momarinty switch, it's a definite on off, a bit like a light switch on your wall or by your power plug if you have that sort of switch, so that you go click, it's on, and click, it goes off. But they're actually like little sliders. They are so small. Let's do the normal thing and zooming in. I realize in this bottom right hand corner it's maybe not the biggest of zooms, but it's a zoom in. There we go. That's it. There's like lots of little switches, and you might find like a ballpoint pen or something like that might be a little bit easier for you to flick them, or the end of a screwdriver. Be very, very careful though, because it is very, like, you know, it's a little bit of plastic. So maybe a plastic screwdriver if you have one, but something that's strong enough not to bend to flip these out of the way. If you've got some nails in tiny little fingers, you might be able to click them, as in I can get to the end ones, but it can be a bit fiddly trying to get the one in the middle when it's, you know, when there's such a lot of them in a row. Anyway, it talks about that a lot more there. Constructing the circuit, as always, make sure the Pico is unplugged. Where are we then? The starting point for our breadboard will be how we left it yesterday, but we're going to remove the 2 buttons and their wires, but keep the red 3.3 volt rail wire in place. Okay, this could be fun. So let's bring it across and zoom back out again so we can sort of see what I'm doing. But there's the 2 buttons that we need to take out, but let's get the wires out of the way first so we don't bend things and whatever else. So it says the red wire. This is our red wire here. Oh, this one that goes all the way down to the lower part of the breadboard. Zoom out a little bit more just to make it maybe a bit easier. Okay, so this one we're keeping in. These two we can remove. Let's pull them out together at the same time. So we've got the blue and the orange wire from that little collection. Just put them in a little pile here for now. We don't want to, you know, we're going to end up with a collection of wires, but we don't want to mess up. We've got the grey wire, if you've been following the colour coding way that I did it. And then this white one as well. And then we wobble out the buttons. Now, it doesn't say to put them back in the box. I'm just going to have a cheeky look down the rest of it to see if they bring the buttons back. I doubt it, because they want us to play around with the dip switches, don't they? No. So I'm just going to put these back into box 3 where they came from. So box 3. Just so we don't accidentally start losing things. We don't want that happening, do we? So just off camera, putting things away. Leave the caps on the buttons, that's fine. Close that up. Put it back in the main big box of things, just so we know where everything is. Now, look, there we go. Box 3. Just in case you don't think I'm doing it. But as I say, we don't want to lose things because they're all tiny and we're quite new to this. So let's have a go. Oh, wrong spot, isn't it? We're jumping ahead here. Whoops. There we go. So we're back. This is what it wants. It wants the red wire over here, plugged in. And then they're the wires from the little collection of LEDs that we got yesterday. Fit the dip switch and GPI wires. We'll fit the fit the dip switch where the buttons. We'll fit the dip switch where the buttons were before we remove them. That just makes things a bit more confusing. Right, we're going to stick them. There is writing on it, and it will say on, then dip. Goes top, and then 1, 2, 3, 4, 5 from left to right. So we're just going to push that in across that little dippy bit. So it's E1 for the top right leg, and then all the rest of them should fit in. As you heard, it snapped in quite well. Gently push it into the rightmost set of holes with the middle of the switch straddling the center break, which is what we've done. The legs on these switches aren't as thick as some of the other components, so don't be too forceful with it. Oops. I think it's fine. It went in. There didn't seem to be any bending of wires. Right. We'll then connect the lower legs to our GPIO pins. There are 5 numbered switches in total, so let's use the following pins for each. Check the Pico pin out map to find your way. We're just going to cheat and use the diagram. Right, so we have the wires. It has the wires we have are the ones that we had before, and this set of, on the diagram, it shows like the purple, orange, green, red and yellow. I wish they would just pick colours of what we're actually sending us. Right. I'm going... Does it really matter? I don't think it really matters. But I'm going to use it this way. The fact that the grey is what they're showing on the diagram as being the purple one. So we need... What pin is that? All the way to the left is pin 9. Which is easy enough because since we're on the first row, they're actually numbered. So pin 9 on the bottom breadboard, going up to, what would that be, pin 5 of J. So on the top board, J5 down to, if we can get it to go in, we did say a couple of days ago that sometimes might be a bit fiddly, to A9. And then I'm going to use the orange one since that's the one colour that does match. We want that to go from J4. Oh, be careful. Mine has done that. That's not so good. Let's try that again. J4 on the top board to A7, because we're not doing the 8 because that's a ground. There's no point connecting that up to there. Then we want a green one. It says, but we're going to pick blue. And that's J. Yep. J3 off to A6 on the bottom board. Sounds like I'm playing battleships or something, doesn't it? We'll take the red one off now. We'll keep that as being red. So I2. We can get that to go in. There we go. And that goes off to A5. And then we've got J1 on the top board going down to A4. There we go. Right, so now, oh, they are being awkward, aren't they? The wires I put away, turns out I need them again. Okay. Alright, makes sense of course because we need to connect it up to the electricity. Alright, so this time around the colours, do they match? No, we're missing the red one of course because that's already been used for the power all the way down to the bottom of the board. That makes sense. Right, so we have the same colours as what we got today. I can see what they're trying to do now, but they should have put that in the diagram. Right, let's get the buttons out of the way. So, across the top, now to connect up the 3.3 volts, we need to put them back, we need to put them in. And it doesn't give you a list of what to do there. Right. Just to keep things together, not saying OCD or anything like that, but it is sort of good practice if you can to use the same colours as what you were using in the first place. So the first one we put in, if you remember, was for switch number 1. Was there. Now it's doing different colours, and it shouldn't really do that because it's a pass through. So those colours across the top, why they've randomized them across the top, I don't know. Not that it matters, it really doesn't matter. So if I'm just trying to get this bottom, this one here a little bit out of the way. So I'm taking my grey wire because that was for pin number 1, wasn't it? Because we've got it here. On the top row, on the top breadboard now, A5. How's this going to work? Really, how's this going to work? I have one, yeah, 4, 5. There we go. It's all right. Just making sure. Right, and then this set here, we're going across to 2 in on that one. So let's try to get that in there. And then the next wire along, we used an orange one. So A4 on the top, and we're putting that into the one next to that one. And then we used blue. So yeah. This isn't going to work. Right, this isn't very good, is it? Because now we've got A2. I didn't think we had enough wires. Right, so where's the rest of the wires we're supposed to be using? I've got 5 wires going from here. 1, 2, 3, 4, 5. And I've got 4 across the top. And yet it wants us to connect 5. Just for a moment, please. Okay, so we're going to have to go back into box 2 to get this wire out. You know, one of the 2. So what I'm actually going to do is undo the white one that I did last. Oh, not that one, sorry. This white one. Oh, that's across the top there. I'm going to put that to one side. It's just over here somewhere. I'm going to use these last 2. It's not exactly good practice, this, but you know, it cuts down on things. So we need, which ones was it now? The top breadboard, A1 and A2. Push them in together as if it's the same thing. Making sure the wire isn't twisted. I'm not separating these because I might need them for the fact that they're together again, but make sure they're not twisted. It's very important that you don't let them twist because it will confuse matters. You'll end up switching the pins. Actually, it won't make much difference. It'll just get power through either way, but try not to twist them. Just thinking about it, sorry. Get them to fit in there. All we're doing is getting power, so it doesn't really matter if we twist them, but try not to. So that's everything wired up now, I believe. Yep. Let's go across to here again. Smell a rat. Congratulations, it's your first rat nest. I have to say, yesterday was a rat nest of wires. Never mind this one. Alright, so yeah, as in I've going to put that wire through that one and everything like that. So I'm just going to take that one back out again, just to make it a little bit neater. It's nothing to do with any functionality, but it's just so I know where everything is later on. Right. That's that. Basically, it describes what a rat nest is, which is basically a bunch of wires where they're crossing over and not all keep smooth. Because it's not the fact of OCD, it's the fact that when you come to try to figure out, is that over there, and is that in that one, and is that in that one, and is that one over there, and that one over there, it makes it easier if it's all not like that. Right, so We've got a lot of wires in the breadboard now, so its final thing you may want to do is just to slightly adjust cables so that they're out of the way of the dip switch as much as possible. Yeah, I can get to the dip switches. Yeah, it is possible. I can get to them. Right, activity number 1, finally. Dip switch on test. Okay. Our initial program will test that the connections are good. We'll run a small program that prints every 5 seconds to tell us which switches are on. This will use everything you've already learned so far, the inputs, pull downs, if statements and prints. Copy the code over and give it a try by changing the switch positions. Okay, this can be tricky with our big squishy human fingers, so while supporting the body of the switch with one hand, use a cocktail stick, there's a good idea, or a wooden skewer or some pointy thing, but not dangerous item, to change the switch positions. Ideally not metal. What I was saying before as well. But yes, a cocktail switch could be a good idea, but I'm not too sure if I have any kicking about. But in the meantime, what I'll do is just use my fingernails. I'll just do that. I'm sure I can do it. Right, so let's copy the code across. Yeah. If some switches aren't changing when you alter the position of the lever, you'll likely have a wire loose or fitting incorrectly. So okay, copy the code. Oh, sorry. Let's plug it in. Haha! Did it say to plug it in? Did it? Did it? I don't think it did. No, it didn't tell you to plug it in. Plug it in. See? Sometimes you've got to think for yourself. Some of us find that harder than others. Right. Let's get this going, shall we? So we've got a little breadboard going. I'm just trying to balance everything up so it doesn't all drag off. There we go. Press the stop button. It's found it again, so we'll copy the code, paste it, and run the code. It's not doing anything right now. So is number 5 working? 5 is on. 4 and 5 are on. Right, let's just flick them all now. 1, 2, 3, 4, 5 is on. So we've wired everything up correctly. Great. So now we can just stop the program. And we'll move down to the next bit. Activity number 2. I didn't say number, did it? Didn't have the hash symbol. The above test script actively gets the job done, but it's not ideal to have the lines just disappear if the switch isn't on. We can make our test program output a little bit more useful by simply adding the else statements after each if statement to tell our program to print something different if the switch isn't on. Give this updated version of the code a try and see what happens. There may be better, more efficient coding way of doing it, ways to achieve the same outcome, but we're keeping things simple and clear as possible whilst we continue to learn. Fair enough. Okay, so get rid of all this old code. Get it in the right place. There we go. Delete. So we need this code now. We'll paste that in. Oh, let me just move back up one line. Paste that in. Run it. So it says they're all on because they were all on. Now what happens? We turn number 5 off. Dun dun dun. Is it going to do it? There we go. Off. So we have a status thing now. Which one did I manage to click off? I can't really tell. There we go. So I turned off. That was off. So 2, 3 and 1 off. There we go. All done. Right. So we can stop that as well now. But this is the thing though, is the fact you really need to be learning the code now. So as we can see from the last bit of code we did, but it's basically the same here as well, is dip value, is it on? If not, print off, because There is no other option. There's no halfway house or anything like that. It's either on or it's off. So that's what we've done. Now we're on to activity number 3. What have we got now then? Let's bring our bar graph display back into code to light it up on the LED of our display for each switch that's set to the on position. We need to bring our LED pins setup block back into our program and then set each LED segment high or low, being 1 or 0 or on or off, within each statement. So yeah, basically if it's high, it's 1, that means on, and low means 0, and that means off. Because sometimes we have to translate. Computer languages are like any other language in the world. You have to translate one to the other, and sometimes I'm no good at real life languages, but probably not even English. But the thing is that you need to start thinking like that. It eventually gets there. You end up thinking in code, not just oh, I need to do this and translate. You just, oh, so that's how I'll do it. When you become proficient, it's a lot further down the line. It's not what you're going to pick up straight away. You should be familiar with the LEDs, highs and low values, so nothing here should be too scary. We've also removed the print lines as we're now using the LEDs as feedback, not text, which is fair enough. Feel free to add them back in. So we can always put the code back in again so it prints, but we're not going to bother because me babbling on is enough. All you're really doing when you come to my videos is, if you're a little bit stuck, have you wired things into the correct places and that sort of stuff? Have you typed in the code properly? Because as I say always, instead of just cutting and pasting, it might be an idea to actually type this out. Gives you, by all means, it depends on how much time you've got in a day, but you'll learn better if you actually type it out and get the practice of doing it, not just cutting and pasting a whole program. Right, so now then, we should be able to press play, and nothing should appear to be happening. Let's try to move these wires out of the way a little bit so you can see the LEDs. I'll turn the surrounding light down a bit so we can see the glowing LEDs a bit more. It's all shadows now. So I'm going to try to put number 1 on and number 5 on. Number 3, 3 and 4 sort of at the moment, but here we go. We've got 1, 2, 3, 4. I'm going to do 2. Oh, if I can flick it properly. And number 4. There we go. So now we've got status things. So now we could do fancy things of, we know that we've got it, because it could be a nest of wires and you can't quite see your dip switches, or they're very tiny in the back of the box, and you forgot to bring your reading glasses, that sort of thing. But you can sort of see that there's a dip switch over here, and you've got feedback of number 1 or number 2 and so on is lit. So let's turn them all off again. Press stop. Move down all the way. So basically that's sort of the same as it was yesterday with pressing the buttons. It's just checking to see, is it pressed yesterday? Basically, is there a value of 1 happening? And of course, when it's switched, that's kind of like on a momentary switch with a flicker switch or a dip switch. It's like someone's stood there pressing the button the whole time, making sure the circuit is closed, meaning that electricity can go all the way around in its little circle, or the other way, depending on which way electricity is going. Right, so activity number 4. We're going to be using our dip switch to select a light pattern program to run on our bar graph display. Our code will include separate blocks of code which will make our display show different patterns. The light pattern that displays will depend on the switch positions on the dip switch. To do this, we're going to create our own functions, so let's explain what they are first. Okay, read what they say about it. I'm just going to summarize it to the best of my ability because it's a lot of things to do. But please read it. It does explain it pretty well, just having a quick glance at it stuff. there's a lot of things you have to do in the basically you have to define it. That's what the def stands for. And then as an example, they've got my function 1. You could call it anything you wanted. Now, as we've already learned with variables, that's kind of like having a word and then having it equal 1, or even that a dog could equal cat. So every time you talk about a dog, you actually got the value back as a cat. Sounds confusing, but that's the whole idea. You can have things mean something else of a value-wise. Now, with a function, it's kind of like having a variable that has its own little program in there. Pushing my hands around and just to hear, but it's basically like that. So if you've got your head around that a word can mean a value, now you're getting your head around the fact that a word can mean a whole little program, which will eventually give a value. So you have to sort of go like calculate something, add it all up, or you need to go do some while loops and you end up having to either add things on or figure out if something is either on or off. You want true or false values. That's sort of how it works. But that explains it perfectly fine on what's happening. But just as a real summary is the fact that a function is a small program that you need some kind of result out of it. It could be true, false, it could be calculations, but you need to figure out what the value is going to be after you've done that little program. And then your main program can then do whatever it is you want it to do, knowing what the functions are. So what can we do for an idea of? So you could have like if it was an everyday thing that you were doing. So I was in like you could have a function called open box, and then say that there was special computer names already in there, but you need it to open the left flap, the right flap, the top flap, and the bottom flap. Maybe they were already programmed into the computer, but now to open a box, you need to be able to do that component. And at the end of it, you could check to see that's all been done. If so, the value at the end of it is true, and then you could go back in your main program to check to see is open box equal to true, and it'd only get true if all the flaps have been opened. It's that sort of thing of doing. Anyway, let's read all of that properly from the functions, and then it talks about the limitations of the statements, but also the fact of you can have something else called elif. Sounds like you're going to say elephant, but elif, which is short for else if. And basically, if the first statement isn't, because remember, if you have an if else, what we had yesterday of like, is a box blue? If yes, that's equal to 1, and if it's not, it's equal to 0. So else equal to 0. If else if though is sort of the other way around. You want it that the fact that is the basically if else if is that if it's not, it'll already start doing that code, and then if it's not that, it'll skip it. It's sort of the other way around. So you do the if else is that you do the code, and if it's not, you do a different chunk of code, whereas the other one it'll do it the other way around. But as I say, just read it everything through, because I'm probably not explaining it very well. And if you've got a better way of explaining it than even what they put in there, then please put it in the comments, because we could all do with learning together. So we've got the code finally. So we'll copy this code in because we've got, I'll have a quick look at this code this time though, because this one's a little bit more complicated. So what we've got is the dip switches, we're setting them up. We've set up the LEDs. Remember we had from yesterday the segments. So we know that they're going through there. Now this is the first function that we've got. And basically the first function, what it's going to do is check the LEDs in the segments. I'll do one, pause for a bit, and then turn it off again. So that'll be sort of like the left to right Knight Rider sort of thing that we had yesterday. Just from left to right though, not coming back again. Program number 2 though is going to do from the right to left. So the function number 2 will go from right to left. So we're going to have to whoop and then whoop with the LEDs. And then we've got the main program, and this time around we've got dip 1, but if it's equal to 1, say that program 1 is running. We'll keep going left to right, left to right, left to right. Otherwise it will do program number 2, which is right to left when it comes to doing the LEDs. So we'll run that. But nothing's turned on right now. So let's turn 1 on. Oh, sorry, turn number 5 on. I said 1, I meant number 5. Now let's turn number 1 on. So we've got that going. Now turn switch number 2 on. And turn 1 off. So there we go. I can turn it all off. So 1 makes it go left to right. Turn it off. And number 2 makes it go right to left. 3, 4, 5 and everything else don't do anything because we've not actually checked for those values. Right. Just making sure you're watching. Right. Now we need to do checking for multiple dip switches. So using the AND statements. So basically what we've got now is the fact that we're let me copy the code across, and then I'll be able to talk you through it a little bit. Right, so as before, we've got everything set up. It's doing LEDs left to right and right to left. Now we're checking to see if 1 and 2 are turned on before running program 1. So they have to both be on before program number 1 runs, and basically the same for program number 2, because dip switches 3 and 4 need to be on before it'll do the right to left. So watch what happens now though. They're all turned off apart from number 1 is on, so it's doing it. Let me just make sure I'm running this code, copy the correct code. It should be that's what's happening. There we go. Sorry, I accidentally didn't copy the correct code across. Right. Turn 1 on, nothing's happening. If I turn 3 on, I've got a bit of a flash then because I'm accidentally knocking other pins. Right, nothing's happening. So I'll turn 3 off again and I'll turn 2 on. Because 1 and 2 are on, it's seeing as that to be 1, and because that's 1 means on or high, it knows to start running function number 1, which is program number 1 in this case. I think they should have maybe called them a bit different. It gets a bit confusing that. But function number 1 is running. Turn both of them off, and we'll turn 3 and 4. It flashes sometimes like that because I'm using my fingernails and not doing it all in one go. So maybe you should get your cocktail sticks out. And now it's going the other way. So I can turn them all off. Click number 5, nothing happens because we're not even checking for number 5. So we'll cut all this away again, get rid of that, and we'll move down to the next bit. Because we saw that in the code, didn't we, that it's checking for and. That's what it needs to be put there. But now we're checking for or. So as an example, is it 1 or 2? So we'll copy this code across. And basically it's the same rules as what it would be in English. Is dip 1 or dip 2. Change to high or 1 or on, all the different ways we can call it. But now it won't matter if we do 1 or 2 to turn the first one on. But let's see what happens when we turn them both on, because that might be interesting to see what happens. Right, so switch number 1, it's on. Turn that off. Turn number 2 on. Yep, only number 2's on. But 1 and 2. Aha. So it doesn't matter because it's 1 or 2. And we can do this for 3 and 4 as well. I can actually, whoop, that's number 2. Let's get number 3 going. There we go. And number 4. So that works for that. And that's day 5 finished. Now, just to let you understand as well that in electronics, the and or and things like that, they're known as gates. So if you want to do a little bit extra reading, learn about gates, because there's interesting things like there's a AND gate, OR gate, a NOR gate, a XOR gate, which is XOR. So have a look at them if you want to do a little bit of extra reading before tomorrow. In the meantime, don't forget to check down below for the links to Patreon and Discord. Hit that like, subscribe and notification bell so you don't miss out tomorrow. But as always, happy gaming!